This is the Building Automation Monthly Podcast with Phil Zito, episode 98. Hey folks, Phil Zito here, and welcome to episode 98 of the Building Automation Monthly Podcast. And in this episode, we will be talking to Andy Marsh of BuildPulse. BuildPulse is an analytics provider for the building automation industry. And in this episode, we're going to be unpacking one of the topics that a lot of folks have questions about. And that is, how can you apply analytics to older building automation systems? And can you even apply analytics to older building automation systems? So Andy and I have a great conversation in this podcast, and we unpack what analytics are, how you can apply analytics to older building automation systems, what can you do if you can't afford analytics, what are the most common issues that you will find, and also how can you build a return on investment for correcting inefficiencies in your building. So with that being said, let's dive into the interview. All right, folks, I have Andy Marsh from BuildPulse here. He's a solution architect for them. And today we are going to be tackling the topic of, if you have an older or what you believe to be an older building, how can you go and take advantage of IoT? How can you take advantage of analytics? What can you do with that quote-unquote older building automation system in order to see some results? And we're going to tackle the common belief that the option you have is to either do nothing or to do massive upgrades. And we're going to talk why both of those options are simply not true in most cases. So, Andy, thank you so much for being here. I really appreciate you taking the time. This is going to be really awesome.
Happy to be here, Phil. Thank you.
Thank you. So the first thing we're going to do is we're just going to dive into questions, and we're going to go through, and I'd love to get what you're seeing in the market. So the first question is, what is the most common limiting belief that is holding back both facility owners and operators, and in some cases system integrators, from looking at their building and addressing efficiency issues?
Oh boy, there's a long list of those I hear quite frequently every single day. Oftentimes we're too busy, and what that really translates into is they're too busy reacting and not being proactive. So they're chasing hot and cold calls. They are literally chasing their own tails on a day-to-day basis. And with some of the analytics platforms, they're basically presented with an awful lot of information, and it tends to freak them out. So they tend to go into a huddle and continue being, doing business as usual. And that's what we often see. One, cost. No, it's going to be too expensive. And frankly, it's not anymore. Two, we're too busy to look at these things. It's another system we have to manage. It's another computer on the desktop. There's a myriad of issues that they tend to come up with, and none of them really hold water, frankly.
Okay. So let's unpack those. So cost. Before I left Johnson Controls and started teaching full-time at Building Automation Monthly, I was responsible for one of our analytics solutions. I had a stint where I did that. And you speak about cost, and that really strikes home, because at least back in 2012, I think it was, one of the common things we'd go in and we'd find is that there was a lot of manual effort. You'd have to do a lot of point discovery. You'd have systems that maybe didn't speak common protocols. And there's just a lot of, I don't know really how to describe it other than just legwork that was required in order to go and implement any sort of, not even analytics, but just retro commissioning, analyzing data. I mean, you name it, the information you needed to go and do quote unquote efficiency, it just required a lot of time and effort. How have you seen that changed in the past
and you're
years?
quite right. So I was a SME for building analytics at Schneider Electric for a while, and we looked in depth at the market. It was actually an acquisition that we were looking to make, and I've got my Schneider head right now when I'm thinking about this. And overwhelmingly across everybody we looked at, you nailed it. It was a very manual process. The point discovery, the point mapping, basically you have to take how you and I might have named our points on an Andover system, a Siemens system, a JCI, Honeywell, et cetera, et cetera, et cetera, which comes up with a myriad of different naming conventions for the same point. So it takes a long time to manually review those, look at the drawings, look at the sequence of operation and determine, yes, that's the point I need. And here's my name that I'm going to put to that. Very manual process. Technology has changed, and it's for the better. So the ability to automatically name these points is a huge time saver. And of course, that converts into a reduced in cost as well. Many companies out there right now are investigating this technology. It's machine learning, frankly. We use it. Machine learning and pattern recognition. Because it still surprises me. In fact, I looked at a system just this week. The points were not named. It was just BV1, BI2, AO4, this sort of thing. And the use of pattern recognition, so modern software technology is now able to sit and watch how inputs, outputs, and fixed values act against each other and determine a name for those things. It was impossible 3 or 4 years ago. But the combination of machine learning and pattern recognition drives down that first cost tremendously. I worked on a system about 6 years ago. Year one fees were $600,000. It was a huge complex, admittedly, but it was primarily due to the onboarding costs. Well, we didn't get the deal because it's very, very hard to get a justifiable ROI based upon those kind of high fees. So we estimate only 5-6% of the market right now actually is using this sort of technology, and it's primarily because of the cost. That is always an off-putter.
Okay. So assume that that is just black magic to me, and machine learning and pattern recognition, that sounds like something out of a sci-fi movie. What is that? Like, as a facility owner, okay, machine learning, pattern recognition discovers points. Well, doesn't my BAS discover points? I mean, what are you talking about here? What's going on?
Well, let's take a look at what analytics really is. So an FDD platform augments your building control system.
What's an FDD?
Fault detection and diagnostics. So we are able to take the building control system points, all of them. So we're not choosy in terms of specific inputs or outputs. We take them all. Along with variables and so on that are built into the system, set points, occupancy points, and the like. We send them to the cloud, 5-minute intervals, and every single point is trended. And that's something most building control systems have a problem with. They weren't built to trend hundreds and hundreds or even thousands, tens of thousands of points every 5 minutes. That just don't have the processing capabilities or the architecture, software architecture built in. So once you're in the cloud, they are run against a predetermined set of rules. And those rules are looking for 2 main issues. One are, how is the building system being operated? Because we've been in this business long enough, and I'm sure people listening to this podcast will agree, some of the things that users do begs belief. So we're looking for issues related to how it's being managed, and we're looking for issues related to the equipment that the system is managing. Things like leaking chilled water valves or hot water valves, leaking economizers, inoperable economizers. We're looking for every single thing out there to determine, wasted energy costs related to these faults. And that's pretty much how we prioritize things, is based on, and everybody in the industry does the same thing, tends to prioritize based on the wasted energy impact. So that's the analytics, and they're automatically applied based upon the availability of points. And what that really means is, if you look at an old BMS, and I know we're covering probably a question that could arise later, but older building control systems tend to have a lower point count density. And by that, I mean they don't all have a pre-coil sensor. They don't all have a mixed air sensor, for instance. And that doesn't prevent FDD being successful. But what it does mean is the analytics are less accurate. They're still able to tell you what is going on, but not necessarily pointing to exactly what the root cause is. Obviously, the more points you have in a system, the better the diagnostics associated with that. So like I said earlier, they really are there to augment the building control system. We still get some people saying, so does this replace our BMS? And of course, the answer is no. Does that answer your question?
Yeah, it opens up a couple more questions. So one of the things I hear then, well, I've got an old BAS. My vendor told me that we can't implement a lot of trends because the system can't handle it. We can't be going and doing analytics or anything like that, whether it's simply pulling data into a database, because it'll overwhelm the trunks. It'll overwhelm the speed of the system. What are you seeing around that?
And that's a very valid concern. I remember a few years ago, I came across a system that was trying to pull 1 minute interval data out of the building control system. And despite them paying a small fortune to upgrade the servers, it just wasn't capable of doing so. So when you're looking at fault detection systems, you really need to be looking at companies that are very conscious of the impact that these systems can have on the operation of a building control system. You're looking for gateways, if you like, the devices that actually pull the data out of the BMS and push it through the cloud to the cloud through firewalls. They also have to be monitoring the data stream that's coming out. And if those data streams start to slow down, it probably means you're overtaxing the trunks, as you mentioned earlier. And therefore, you want something that will automatically slow down the read cycle. So it's important that we try and pull data out of a BMS, and the impact on the BMS should really be nothing more than pulling up a heavily populated graphic. If you come across a vendor that does not really truly address the speed concerns, walk away. Because at the end of the day, you may put a system on top that you say is going to save this client tens of thousands of dollars a year, but if the BMS becomes inoperable, it won't last very long.
So now let's look. You said about owners and operators and just adopting. So what are you seeing as the biggest challenges to adoption? I heard about the kind of maintenance rat race. I get that. That's for everything, right? No matter what you do, you're going to run into that. But what other things? Because that seems to me, the biggest barrier doesn't seem to be cost and implementation. It seems to be actual execution of this.
That's a really good point, because most of these fault detection systems are cloud-based. They're SaaS models, in other words, it's an annual license fee. And unless these things are used, they're not going to be paid for the second year. Because if you don't react to the issues that are being presented to you by these platforms, you're not going to save any money. If you're not going to save any money, then why invest in the second year? So it's very, very important that our listeners today and their customers are trained to become experts on the system, and to make sure, for instance, that you make sure, you, the purchaser of a system like this, that your people are actually using it to the best of its ability. It's presenting hidden faults that a BMS probably did or did not know about. I mean, there's some hidden ones in there that, frankly, the capabilities of a BMS aren't able to diagnose because of the lack of trending capabilities. But if it's like with any software package, energy management package, it's useless unless it's used. So once you get these systems deployed, it's vital that we follow up on a regular basis with your customer base to make sure that it is being used. Certainly, that's one of the follow-throughs we have, is just to make sure on at least a monthly basis, we give them a call to see if they're using the system, and to, if they've got any faults, any issues, any bug requests, feature requests. It's a customer-focused event, but it certainly keeps them using the system, and that's vital. So that's the biggest issue we see. It certainly prevents year two sales, that's for sure.
So let's shift gears real quick, and let's assume that they don't have analytics. They're not going to get analytics. what are the three most common kind of energy efficiency issues you're seeing in buildings that just folks could tackle if they change their mindset?
There's some really simple things. I'm sure we've all seen these as well. Look at time schedules, trim them back, make sure they match real occupancy for the buildings. Set points, make sure that your night setbacks, for instance, are set reasonably well. I'll give you an example of that one. Just recently, this week, we onboarded a university, and I couldn't help but notice VAV's rooftop units were cycling all night long. Well, the nighttime low limit was at 65 degrees. So systems shut down at 11 o'clock. By 1 o'clock, systems are starting back up again because somebody mistakenly changed that set point. There's only a few in the entire campus, but it's causing an issue, and it's such a simple fix. Another one is most BMS systems have a decent graphics package. They will tell you an awful lot of information just by looking at it. So if you look at a graphic and you see that the BMS says the chilled water valve is 0, it's closed, and yet you can clearly see the discharge air temperature is lower than the mixed air temperature, then that valve is actually leaking by. So there is a lot of easy things you can do with a BMS. Setting up trends. Now, trends, as we've already discussed, are problematic. It's tough to trend every single IO and every single occupied point, every single set point on an entire campus, an entire BMS. But you could do it building by building. It's a very manual process and it takes time, but it will pay off in the long run. So there are some very simple things you can do.
So let's go back to the valve leaking by scenario. So one of the things I want to unpack is kind of that thought process of cause and effect. How are you seeing cause and effect being addressed in buildings? And I know this isn't a very clear question. It's kind of vague, but it just seems to me, and maybe it's just the exposure I have to the people I have, but it seems that people are so reactionary that they're not thinking about cause and effect, or maybe it's an educational gap. And I'm not sure which one it is. But for example, I mean, you would think, right? The valve says closed and the outdoor air dampers are closed. The mixed air is 70, but yet your discharge is 53. That should indicate that, I mean, you don't magically have that much heat loss. But yet maybe I'm missing something, but it seems like there's just that thought process isn't happening. And I don't know if it's graphics or alarms or just people are too busy.
There is obviously an element of alarm fatigue, but things like that tend not to be.
What's alarm
just too
fatigue?
Many alarms. You tend to just ignore them because there are so many, even though most of us have building control system experience and the platforms to be able to prioritize these things, they still tend to get ignored. Especially, well, the only ones that don't really get ignored, frankly, are breakdowns. If something stops working. In this case, let's dig into that chilled water valve issue. Unless somebody calls to say I'm cold, it'll probably get ignored. One of the company that first brought me to the United States about 15 years ago, extremely large shopping center developer, and one of the first things that we did was create an extremely large enterprise level BMS. From my desktop, I could reach into almost 150 shopping centers around 38 states. And it was surprising what we saw. We saw examples of this chilled water valve all the time. And when you call the operational director on site and say, why hasn't this been repaired? Well, there's no problem. Nobody's complaining. And it really isn't until you put a dollar value around these things that they start to pick up and listen. Because in the past, nobody's complained. It's not cold. We'll ignore it. No big deal. But if you say that's costing you $75 a day or $6,000 in the last 4 months, then it gets attention. Because now they can go to their manager and say, I need to repair this. Here's what it's going to save you over the next year. That gets attention.
So, with that example, are you seeing a reluctance in folks who don't have financial responsibility? So, I'm a mechanic or I'm a tech, or I'm a facility manager, but not a director or VP. I'm simply responsible for keeping temperature good. I'm not being essentially judged by financial performance and I don't have a tie. Are you seeing that tie being pushed down? Are you seeing the requirements for managers maybe being tied to energy or maybe a better connection? Are you seeing that? And if you're not seeing that, what would you recommend around getting that to be kind of adopted by the culture?
Yeah, Boiler Room Bob is less likely to use a system like this than the facility director or actually the energy manager on a campus, for instance. They're the two people that definitely have financial ties around the performance of the facility. Generally speaking, your plant room guys will just see this as noise. They'll see it as more work for them to do, another system they need to manage, when the reality is they can pretty much stop looking at a BMS on a day-to-day basis, although we don't encourage that, and actually just concentrate on, let's say, fixing 2 or 3 things a week. So when these systems bubble up faults based upon, prioritized energy wasted, go and pick the top 3, fix those. And actually in the past, what we've shown, and this is just some anecdotal stuff, people tend to buy fault detection platforms to save energy. That's their goal. What really happens is they save energy and become a lot more efficient. So staff basically, here's a real example. We had a campus up in the Northeast, and they estimated they spent 300 hours a year managing set points. It was a huge campus. With the advent of a fault detection platform, it bubbled up in a pictorial manner where all of these set points were set, and they now estimate they're down to 25 or 30 hours a year. And using the platform as well, they're able to be very accurate in terms of, well, I know exactly what the problem is because the fault detection engine told them that. And they were able to go straight to that problem. They took their toolkit, they knew exactly what they required, spare parts, etc. And in this particular case, over the past 18 months, it's freed up one of their staff members enough that they've started to do some of their own BMS install. They're a local shop themselves, but they're actually freed up one of the guys enough to actually spend time physically installing and programming these things. So that's just a value add to a fault detection platform.
So that brings up an interesting question. Are you seeing any system integrators? I've seen commissioning agents utilize fault detection and analytics, maybe for retro commissioning, but are you seeing any? I know that the competition's tight and controls. I've often said that the control system doesn't matter as much as the installer, programmer, and service guy, that it's only as good as the people executing it. But are you seeing any integrators or just companies in general trying to use these kind of platforms to do a value-added service? It seems like that would be some high-margin work that would generate a lot of retrofit opportunities.
You just hit the nail on the head. So I did work with one company that came across from Europe quite a few years ago, and they got set up. He was an American guy. He just happened to work for, I think it was McQuay back in those days in Europe. And in Europe, they've got a slightly different model, which is slowly but surely appearing here, which is outsourcing. So there's a lot of sort of outsourced building optimization companies in Europe. And they very much use this for 2 purposes. One is obviously to optimize the operations of the building from an energy perspective, but to 2, to drive additional revenues. So what that really means is they're able to bubble up potentially hidden faults with the operation on a building. It could be these valves that we keep talking about, or economizers not working properly, and more readily get approval to proceed and repair and service because they're able to predict what the savings will be. Going back to the conversation earlier, about people won't fix it without the monetized value associated with it. Same thing. So we're seeing a lot of service organizations now getting on board with fault detection platforms because they can see that it will drive additional revenues for them. And of course, it drives additional stickiness with the client as well. So you really start to become a trusted advisor to that customer instead of just being a vendor.
Now, I realize some folks who are listening to this probably right now think, well, of course, we're talking about analytics because you work for an analytics company. And I would say that most of this stuff, it's going to be much more effort intensive, as you and I talked about earlier. But most of this stuff can be done with trends and trend analysis if you have the right data points. But I mean, let's be honest, folks have been specifying trends, and how often do they actually look at them and have the time to do the analysis? And can they pick through all the data? But I think we'd both agree that it can be done. It's just very effort intensive. Now, with that being said, what kind of efficiency issues are simply not going to be found kind of using that approach? Because there is some stuff I would imagine that it's either got too many interrelated trends, and because of that, it's just hard to see the connection. Does that make sense?
Yes, it does. So we went back to the trend capabilities or trending capabilities of a typical building control system. Imagine trying to pull up a densely populated air handling unit. You've trended every point on the system to make sure you've not missed anything. And then you're trying to see that trend over, let's say, a 6-month period. You might as well get up, walk away, go for a walk around the campus, come back, and it may have finished, it may not. So the building control systems have a real problem handling big data. They weren't designed for it. Now, more modern ones are becoming more cloud friendly. They're built with that purpose in mind. So you won't have those issues with the brand new systems. But I think a lot of what we're talking about today are those, 5, 10, 15-year-old building control systems that people say, what's the point? We can't make this cloud ready. Yeah. And the reality is it's very simple to make these things cloud ready. The manual intensity of working with a BMS is primarily caused around the issue we're talking about right now with the trending. It wasn't built for it. Mm-hmm. Can it do it? Yes, but it's incredibly slow, and you still might miss things because it won't prioritize based upon costs. So you're still going to uncover things after an immense amount of effort, but unless you're able to put a monetized value on that, then you're less likely to get approval to go and repair it anyway.
Yeah, and I've also found that, because when I used to do this before analytics, I would have to go and use Excel. I'd pull everything in. I'd have to punch in equations, and then I'd have to go and do this for each system, and the equations would change based on what I'm trying to prove, and it was just a lot of manual effort. But with that being said, how are you seeing folks define return on investment? Because that seems to be a topic that is complicated because, one, they've got to trust that the equations the system's using are accurate. 2, they've got to provide good data. But then it seems like return on investment is different. We've mentioned labor reduction. We've mentioned energy. I mean, energy's the easiest to define, but I don't know. Maybe it's just me, but I feel like the focus on energy has kind of declined over the past year or two, or maybe it's just who I'm talking to. It seems like the biggest gap is that we're losing a lot of talented people, and people have manpower and skill set gaps. That seems to be the largest area I'm running into. Maybe it's because I run a training business and you just, you kind of see what you need to see. So it could be that.
You raise a really interesting point. I wrote actually, it's in draft mode currently, but a white paper on that very subject. So there's a huge amount of experience that's going to be retiring out of that workforce in the next 3 or 4 years, a huge amount. and they're not being replaced by people with similar experience and skill sets. They're being replaced by people who are very much used to staring at a computer screen, an iPhone, and not knowing what a central plant would be if they tripped over it in the dark. Modern cloud-based analytics and the outsourcing that we talked about a short time ago is the answer. So no longer do you have to have a recognized expert on your staff. You can have a remote one that's part-time. And that part-time remote one comprises of a fault detection platform and some of your listeners who are experts on the building control system. So why would they employ an expert on staff at a fairly high rate when they could actually outsource that at a far reduced cost to someone else? And that's what we're seeing a big shift in, especially in Europe. It's been very prevalent there for a number of years, but I'm seeing it more and more here too.
So that's a really interesting question statement rather, because I was at a city in Kentucky. I won't get any more specific than that. And they had a hole in the side of the building, literally in the air handler room. And that's just kind of the level of repair that was going on in the building. And the facility director said, analytics sounds really cool. Even you guys just going and doing better trending and graphics sounds really cool. But I can buy 4 fan coil units for the price of what you're talking about. And I was like, okay, but really what's the issue? And, we started having lunch and he's talking about, they've got tenured guys who, they're 50 years old. They're worried that this system comes in and they're all just going to get replaced. So that's one thing that always pops in my mind when I hear folks say, well, yeah, this can augment. And my answer usually is, well, you've got so much backlog of deferred maintenance that you're actually probably going to have more work when you implement a system like this. I don't know. Am I telling folks the right thing, or is that not true? Or
yeah, I agree. And I've done training for people in the past on this, and oh boy, do they look frightened, because they're seeing these hundreds and hundreds and hundreds of issues coming up on the page, and they're wondering how on earth they're going to address all of these things. The reality is, and I think I mentioned this earlier, just pick the top 2 or 3 on a weekly or a monthly basis. Once you've repaired them, go back, take the top 3. We have a customer that did just that, and they actually have provided permission to us so we can use their system as a live demonstration rather than just a demo site. It's actually a live system, and they have so few faults now. I don't want to use it. They've actually cracked the problem. Now they're in what's called a continuous commissioning mode. So one of the problems in the industry with retro commissioning is typically it's done, and 4 or 5 years later you need to go back and do it again, because the second you walk out that door, the equipment starts to degrade in performance. People make the incorrect settings, time schedule, set points and the like. Programming changes are made. The efficiencies start to degrade. 5 years later, you pay for it all over again. Where this particular campus is now, they've optimized the performance of all their equipment, and now the system is sat watching for problems. No longer do you have to wait 6 or 7 weeks for a high utility bill to come in, scratch your heads wondering what happened. The system now will watch your system. It's like having Boiler Room Bob sat there watching the BMS all the time for issues if and when they occur. So that's where we see the market going after implementation. I think it's a key point. And it can be scary, but part of the process is training. And the training that we provide is basically built around how you use this system in the best way. Don't try and fix everything, because it will never work. Fix the top 2 or 3. And it becomes very, very manageable very, very quickly.
So I want to expand on that. Can you talk about the cascading effect of maybe you find an issue with a chiller, and because of that, is there a cascading, and I know this is totally a leading question, but I think folks get so caught up in the day-to-day grind they don't see this, and that's why I wanted to bring it up, is the cascading effect of fixing a main system on downstream
Oh, it
systems.
does, and
Does
it's
that make
huge.
sense?
Absolutely huge. And conversely, also, you have to also consider those downstream systems. Um,
Mhm.
Years ago, I worked with a company that only dealt with the air handling units and built up plant. They ignored all the terminal devices. There was an awful lot of energy savings to be had with those terminal devices. But going back to your question, it's absolutely key. There's a lot of faults in the field that are being caused by a very rudimentary issue with this central plant. If your central plant isn't able to deliver the chilled water at the right temperature and flow rate to satisfy the the cooling demands across the campus, then it will cause a lot of head scratching. And if you don't address the root cause, it'll keep doing it and you'll never get ahead of the game. So
Mhm.
decent detection systems always do a root cause analysis. They're always looking for the causation of the particular issue that's being worked on at that time. So a lot like a building control alarm point, you will always have a trigger point in there. If this is not valid, then ignore what's going on. An example being your chilled water plant. If your chilled water plant isn't running, ignore that warm call because there's nothing you can do.
Yeah, you know where I see this happen a lot is at universities where they have a separate plant services group, and usually that plant services group may be running some sort of
Hmm.
industrial control software, and then you've got your buildings group. And because the buildings group can't see what's going on with the central plant, they don't see those issues. So yeah, that's something also, and you'll probably chuckle at this. I remember folks were doing chilled water reset off valve position on all the air handlers, but they had mapped in the preheat valves and
Oh
not
boy.
the chilled water valves for the
Yeah.
reset calculation. And that was, they could never figure out why the chiller was acting in reverse.
Mm, yeah.
So are there any other kind of issues you're seeing other than equipment and building efficiency that facility operators and managers are
Yeah,
focused
I think
on?
I touched upon it earlier. Workforce efficiency is something they are big time, going at. Obviously, cloud-based work order management systems are key.
Yeah.
The ability to tie in disparate systems on the campus into a work order management system is able to drive additional efficiencies. And I think I mentioned earlier that packages like fault detection systems also aid in that because no longer are they left scratching their heads wondering what's the root cause of the problem. They're being told what the root cause of the problem actually is. So staff efficiency is key. And on top of that, once you have these systems dialed in, a natural effect actually is an increased comfort level within these buildings, which drive additional team
Mhm.
efficiency. So now your people are working more efficiently because you've got now a really nice, comfortable environment. So there are two areas that we see quite frequently these days.
So, with the exposure you have to a lot of different customers, what are you seeing as adoption of work order management system? Because that one still kind of befuddles me, I guess would be the word. I don't see it included in a lot of new builds. I only run into it on, you know, who I run into it the most with is companies that act as real estate trusts, and they own a lot of and manage a lot of real estate as kind of investments. I see them looking at work order management and contractor management and analytics. I see those folks, but universities, hospitals, I don't see a lot of them implementing work order management. I'd be interested in what you're seeing, if that's just my exposure or
No,
you're
I'm
seeing
absolutely
something
seeing
different.
that. And you come across it all the time. Oh, we use a spreadsheet system. We built a little database system.
Yeah.
And I think it's because costs. So we talked about costs earlier. It used to be very, very expensive to stand up a fault detection system. It used to be very, very
Hmm.
expensive to stand up a CMMS system because you're buying the software. With the advent of IoT and cloud-based services, CMMS is becoming very, very, very affordable. And because they're cloud-based, they're also very easy to integrate with those other systems. I mean, such as a fault detection system. So you can pump up automatically certain levels of issues into a CMMS to have work orders, automatically generated based upon this. So I think that's a big reason why we haven't seen it adopted as much as it has. But like everything, the cloud and IoT is bringing down first costs and certainly increasing interoperability.
So earlier you were talking about the kind of more distributed services model, the kind of contracting model. And I think that is interesting. But what I think is more interesting is as an industry, and I think you'll agree with this with your background, is that BAS providers tried to be everything in the past. And I think they kind of had to, just due to the immaturity of the industry. But what I'm seeing nowadays, and this is kind of where a lot of folks get confused, is this whole IoT concept. I think folks hear IoT and they think of all the messaging they're getting around smart homes and jet engines that relay data back, but I think it's much simpler than that. I think it's like taking a centralized maintenance management system and taking an analytics system and taking a BAS system and tying the three together. And I wonder what you're seeing as far as reception around that goes, because I know from experience it's a lot easier than most folks think it is. I know that the contracting process doesn't really support it, but I'm just curious what you're seeing, what pushback you're seeing around that kind of misunderstanding, just general thoughts.
And you're right. You think about building control systems, they've really been in the IoT market for well over 10 years. The ability to have a central, server base in one state and have 20, 30, 40, 50 buildings across the entire United States. That's really what we're talking about. It's the Internet of Things, right? Internet of everything. So BMS have been an IoT player for a number of years, just not as we now consider it from a cloud perspective. The difference being, obviously, is that you're no longer buying software. You're in effect, you're leasing it. You're paying an annual SaaS license. A lot of pushback we hear and we get every single day is, well, my system's too old. It's a legacy system. It's a legacy Siemens P1. We can't possibly connect that to the cloud. Well, yes, you can. And it's not complicated. So you don't have to be a rocket scientist. You really are looking for someone that has a plug and play sort of device. So you don't have to spend too much time on site and it's not a complicated process. And I'll give you a story. A few years ago, I worked in the healthcare structures for critical power systems. And some of the generators we were connecting with, older than the Ark. They're probably 40, 50 years old. But with a small retrofit kit, they were IoT ready. You would never have thought it. You walked into this shed to find a generator sat there that you could actually bring it onto the cloud, or at least make it smart enough by spending a day adding some sensors and boom, you're done. So it doesn't have to be complicated. It doesn't have to put people off. It's easier than you think.
Yeah, and I think that's where folks get caught up. I mean, let's just take that generator example for a second and let me unpack it and see if I'm thinking properly, and correct me where I'm wrong. But I just kind of want to do this exercise to make folks feel more comfortable. So you've got a contactor, you've got a starter, you've got some switches. So you'd probably want to put some sensors on a couple of the legs of voltage, right? You'd probably want to put a relay in there. You'd probably want to put some current sensing. And then you put those things and they go into a basic input-output board that has either a cellular or a Wi-Fi or some sort of connection, and then now you've got data pulled out. I mean, that's pretty much it, right? I mean, what did I
bang
miss?
on, yeah. But I mean, there's a few additional points we'd probably add to it, but that's exactly the process. It's like going to an air handling unit. You know exactly what you're going to put on it based upon the equipment that's there. Are there valves? Yes, we'll put an actuator on there. Based upon where the actuators are and the coils, you put some sensors on there because that's how you're going to control them. It's the same way, or the only difference being that you're now sending it to the cloud instead of sending it to a local machine.
Now I'm kicking myself because I realize that a lot of folks have an objection to the cloud. I don't think it's as bad as it used to be. I actually saw this company Codora that does cloud hosting of Tritium servers. And I just want to take a second to unpack that. What are you seeing around objections to cloud? How are you handling those objections? Because I really should have covered this at the beginning, because I don't want folks to, they've heard the word cloud a ton. And I tell folks cloud is someone else's data center. But I mean, what is it? What are the common objections? How do you deal with them? Are there misunderstandings?
Yes and no. So you think about the whole process, and you can't just think of the cloud as being it. It has to start with what you're going to plug in to get the BMS data out. That has to be very secure, and it has to be set up in a secure manner on the network. So typically, our devices sit on a customer's network. Now, it's a one-way push. We only push data out through the firewall. There's never any ability to go back in to a site. That's a very, very typical objection we hear. You know, do you need access? The answer is no. Internally, the port where these devices are plugged into have a very defined number of IP addresses locally that the device can actually reach. So these are your building control system IP addresses only. So that also negates a lot of their concerns. Another typical one is, well, what happens if it's hacked? What happens if somebody tries to plug into this device locally? Well, the way we address that is our platform actually shuts down. You try and hack it, the system goes into sleep mode. It doesn't work any longer. It stops all communication. You try and plug into a USB port on this device, it will shut down. Once we have got this thing onboarded, in other words, completed, any attack on that device, physical or software, will make it shut down and go into protection mode. Mm-hmm. That's how we protect it internally. We then push.
Yeah, well, let me pause you before you go to externally. Isn't there a bigger issue if someone is physically accessing your system?
Yes, but most hacks, as you probably know, come from internal.
Yes, I agree, but that's not a vendor issue. That's, you putting something under the facility's desk and wondering why someone hits the surge protector and it turns off. I mean, there's a certain level of responsibility on the owner to not put stuff in the lobby.
Oh yeah, we always advise it should go in a data closet, right? So it's under lock and key. That's what we normally. Yeah, that's what we normally say.
I just wanted. That's something that always makes me chuckle.
So on the northbound side, the cloud, there really are only a couple of really good, well-known ones. I mean, AWS is the one we use. A lot of people use Azure, Microsoft, Amazon Web Services. So it's the Amazon cloud. And frankly, the security of them is huge. This is their business. They can't. They can't sell, you and I web space, server space on their farms unless it's a secure offering. So I'm not responsible. Providers of fault detection systems are not responsible directly for the security of their web services. Huge corporations like Microsoft and Amazon are. So end to end, it's a very secure process. And remember, the data we're sending up into the cloud, it's not financial. It's building control data. If you hack it, you're just going to get to find out who got what room at what set point. So there's really nothing you can do with that data from an external perspective, and especially given the fact you can't drive back in to the building through that firewall. So it's a very secure one-way process.
Mm-hmm. Now, what about two-way control? What are you seeing? Because I mean, I think that's the next step. I think there's a huge cultural shift
Mhm.
that has to happen before folks are comfortable with letting a
Yes.
system automate
Yes.
changes. But
Well, and you're
what are
right.
your thoughts on
It's
that?
coming. I actually worked on a pilot system in New York a number of years ago, and it probably took 5 months of constant wrist slapping of the central plant engineers to stop them overriding the automated changes. And the first week they did,
Hmm.
we saw quite nice drops in usage. So it definitely improved the situation. So culturally, yeah, we're not there. Will we be? Yes. And I think it goes back to this earlier thought that we had on the lack of trained resources that some of these facilities are going to have.
Mm-hmm.
Indeed, we are actually piloting something like this right now with a number of clients. Fairly simple.
Mm-hmm.
Just the ability to manage set points across broad, disparate campuses. Time schedules, very simple things, hydronic loop optimization. So going back to your talk about mapping the preheat valves earlier, we've got the ability to actually monitor the valve positions and change the loop pressures, which in turn optimizes the
Mm-hmm.
central plant delta T's. So we're looking at an end-to-end optimization, and that's actually done
Hmm.
locally. So, albeit it's an offering we're going to have, the actual smart resides on the gateways. So there's still no
Yeah.
push back through that firewall. So it's still a secure process, but people have got to learn to trust some of these automated systems in the future because they will optimize the operations.
Hmm. Interesting. So final question here. So let's assume that for whatever reason, the user, owner, operator, whatever, they can't make this mental leap to analytics. What I would argue that using trends and analyzing data is analytics, just albeit not automated, but that's a whole nother topic. Um, but they can't make this mental leap for whatever reason. What can they do? How can they convince themselves or maybe convince their management that this is actually viable?
Hmm, that's a good question. Um, we have, and we continue to get customers coming to us with that same conundrum, right? So they're convinced that it's the logical next step, but they really have to go through jump through a number of hoops in terms of, so here's what I do on a day-to-day basis, right? So here's what I have to do to try and find these problems, and I'm not finding them all. They have to really paint a very bad picture in terms of the BMS, unless it's been upgraded recently. The BMS isn't that user-friendly
Hmm.
for handling large amounts of data. So oftentimes it's simply impossible to use the BMS to do some of this extensive troubleshooting. The most maybe you can take a look at is a 1 week trend. With cloud-based analytics, they're taking a look at that same trend over a 6 or a 2 year period almost instantly. You could never do that with a building control system. So it's the first thing, certainly when I was an end user, my boss would say, well, we've bought a really expensive control system. Surely that can do it. And unless you really know what you're doing, it's tough to argue with that particular thought because it should be able to do it. At the end of the day, these platforms really are just taking the data that a building control system has already got. But the biggest difference is it was designed for that specific purpose, whereas a building control system was not.
Yeah. Interesting. Yeah, that's kind of the biggest objection I would always hear is, well, you're the BAS, you should be able to do this. And it's kind of like, yeah, I totally see their logic, but at the same time, I I kind of think to myself, well, that's a whole nother set of skills. I mean, you've got machine learning, as you mentioned, you've got analytics, you've got cloud, you've got all these skills, and mainly in my experience, BAS manufacturers are mostly focused on hardware engineering and the visualization piece.
I think tomorrow's building
Finish
management system will start to include a rudimentary set of building analytics. They have to. Certainly, I worked on a project 3-4 years ago with the company I was with to see what we could fit on board these controllers, and I use the word fit very, very carefully, because oftentimes these controllers come with a finite amount of memory, and trying to shoehorn additional code in those things that comes, shipped off the production line is problematic, because we don't know what the customers are going to do, how much code they're going to do, what it's going to connect to potentially. So it's rife with issues, but I can definitely see in short order your big control system manufacturers shipping stuff with a level of fault detection on board. And that will start to address the problem, because no longer are you necessarily having to farm out to another company. You've probably got to pay an additional license fee to JCI, Honeywell, Siemens, Stafer, the whole kit and caboodle. But that's okay. It's going to be an easier sell. It's like buying options or upgrades on a car package. So I think
that's an interesting statement. It's going to be an easier sell, because I don't see that necessarily with the contracting tier, with plan and spec and how projects are done. I mean, it's a race to the bottom.
It is. But once that package is installed, you win the deal, you put your control system in and you're doing the service work, that's the time when vendors will start trying to upsell. And if you do have an onboard package, an option package for fault detection, then that should definitely be a good time to go and push it, because especially if it's built into the software that you've already bought, it's just switching on some license keys. Then it's so much simpler than having to put a black box, an integration box on site, and then shipping it out to the cloud, and all those IT concerns that you typically get, they go away because now it's built in.
So what I heard you say is BAS needs to adopt the freemium model.
Yep. They do. And they will.
We're going to have freeware.
Oh, yeah, it's free until you want to use it.
Exactly. That's funny. Okay, this has been really good. I think this is going to help folks understand a lot of these concepts that I think are just kind of muddy. Is there anything as you leave this that we didn't cover that you think, because it's kind of that curse of knowledge, right? I always try to take the perspective of assume I don't know anything, and not saying my listeners don't know anything, but I'm just saying that they may not have the same experience you and I have. And what do you wish someone knew about this topic?
It's nothing to be worried about, nothing to be scared about. It's not complicated, and nor is it particularly expensive anymore. The upsides far weigh the downside of things. The upsides being it can increase your stickiness with your client. It can increase your revenue stream. In other words, you'll get more service orders. And you are left with a customer that will keep coming back for additional work because you're now somewhat of a trusted partner. So you're no longer a vendor. So don't be scared. IoT is here. Don't wait to embrace it. They'll certainly help you drive additional service revenues. So let's go.
Well, I hope you enjoyed that interview, and I hope you learned a thing or two about analytics. And if you would like to learn even more about building automation, then I encourage you to go to buildingautomationmonthly.com/98. Once again, that is buildingautomationmonthly.com/98. There you will find a link to the show notes with timestamps for this episode. You'll also find links to a bunch of other information, like the previous 97 episodes of the podcast, as well as blogs and guides that you can use to learn building automation systems. And if you'd really like to take your knowledge of building automation systems to the next level, I offer premium online training courses that will teach you the fundamentals of building automation systems, how to design building automation systems, and how to work with information technology. 3 of the most challenging areas for BAS professionals. And my online courses can be accessed at buildingautomationmonthly.com/store. And there you can learn more about the programs that I offer at Building Automation Monthly. Thanks for being here. I really appreciate you listening, and I can't wait to talk to you again next week. Take care.